Hello everybody, welcome to A-Level Physics and Mathematics. In this section, we are going to discuss about an essential exercise in rotational motion of an object. Okay, so first exercise is say that the rope is wrapped many times around the pulley within radius of 20 centimeter. Then calculate average angular velocity uh, when the pulley lifts the bucket to 10 meter within a 5 second. Okay, so to calculate this exercise, you need to understand what is happening with the pulley as well as the bucket. Okay, you need to understand the basic scenario because, as you can see from the exercise, you can understand that there is a linear motion as well as rotational motion. Okay, you need to understand the relationship between the linear motion as well as the rotational motion of the rope. So let's say you have a bucket. Let's say you have a pulley system. Let's say this is a pulley. Okay. Let's say this guy is pulley with. Sorry guys. Let me just go. Let's say like I said, this is a pulley, and then this is a pulley system with this is let's say this is the center of the pulley with a radius of 20 centimeters. Okay, and then we have a rope as well as what's the bucket, right? So let's say this is a bucket. Okay, let's the kind of bucket, and then we have a displacement. We have S, or which is basically a linear displacement, right? Which is 10 meter, and then the time taken to lift this bucket, which is equal to 5 sec, right? 5 seconds. So that is it basically, and then find out this. You can basically you will have a given term already, or you can write like this. So given is equal to, we do have a linear displacement which is equal to 10 meter, and then we have radius of a pulley system which is equal to 20 centimeter, meaning that 0.2 meter, right? And then we have a time taken which is equal to 5 sec, right? That's all. And then now, like I said before, you need to understand the basic relationship between a linear motion as well as a angular motion of an object. So to find out, the required term is angular, or we call it average angular velocity, which is question mark and then say solution. So average angular velocity is equal to basically changing displacement upon changing, let's say changing displacement or angular displacement upon changing t, meaning that we do have only time, or this is a change in t, and then this is we don't have a displacement at the moment. So as you know that from linear and then angular displacement relationship, which is S is equal to linear displacement is equal to time multiplied with uh, angular displacement, right? From this, you will get the angular displacement is equal to linear displacement upon radius, or yeah, we call it radius, so which is equal to linear displacement is 10 meter upon radius is 0.5, I mean 0 meter, which is equal to, you will get 0 or 50 rad. We call it radian, or yeah, we call it rad or radian. So using this, you will find out the average angular speed, which is equal to, you will plug this guy over here, and then we have time taken as well. So, like I said, you will plug, or you will, this is a time taken change in t, which is equal to, basically this is a theta, okay? So, what is happening, which is theta, okay, which is equal to 50 rad upon 5, right? 5 seconds. So average angular velocity is equal to 10 rad per second. Okay, that is it for this question. Let me know if you have any question in the comment section. I'm happy to reply to you guys. And then could you please subscribe, share, like, and then like this video with your friend. That will help me a lot. Okay, so let's proceed with next exercise, which is a wheel is rotating. I mean, a wheel is initially rotating or turning with the speed of 200 revolution per minute. Uniformly increase its speed to 600 revolution per minute within 8 seconds. Then calculate average angular acceleration of the wheel in rad per second square, as well as the number of revolution turned during this 8 seconds. Okay, to find out, you need to understand the basic what is happening with this wheel. So to calculate this exercise, let's say you have a wheel. Okay, let's say you have this is a wheel. Okay, let's say this is a wheel, and then let's say this is your point of interest. Let's say this is initial velocity, as well as this, like this, another point of interest, which is equal to, let's say, final velocity. And then this, the wheel is moving from this point to this point within 8 seconds. Okay, which is within a time within a time t, or you can say 8 seconds. So that's it. So you can write this formally over here. What you can do is, so the given term, like I said, we have, let's say, given term is average, I mean initial angular velocity, which is equal to 200 revolution per minute, as well as final angular velocity, which is equal to 600 revolution per minute. Okay, and then a time taken, which is equal to how much? As 8 seconds, right? So that's it. And then required term is equal to A is what? Angular acceleration is equal to question mark. B is number of turn. Okay, number of turn. That is what you need to calculate in this question. So find out, you need to convert this unit to standard, or we call it an SI unit of velocity, or basically angular velocity. So to calculate this from, as you know that from one revolution from from the circumstance of a circle, one revolution is equal to 2 pi rad, right? 2 pi rad. And then 1 minute is, which is very simple, 1 minute is equal to 60 seconds, right? So from this, you will get that 1 revolution per minute is equal to 2 pi rad upon what? 60 seconds, right? Then 1 revolution per minute is equal to, you will get from here, pi rad upon 30 seconds. Okay, 30 seconds. Then you can just plug this guy over here, because one revolution per minute is equal to pi upon pi rad upon 30 seconds. Okay, so to find out the initial angular velocity, which is equal to 200 revolution per minute, means pi over 30 rad per second. Okay, and then from here you will get that 220 pi over 3 rad per second. Okay, per second. And then for final angular velocity, which is equal to 60, okay, revolution per minute, I mean per minute, is equal to pi rad over 30, right, 30 seconds, or you will write look like this. It's supposed to be rad per second. Okay, then from this you will get that the 20, right? It is just 20 pi rad per second. Okay, now we are done with conversion from the revolution per minute to standard or SI unit. Okay. Now, what we are going to do is we can calculate, we can calculate average angular velocity. So, average angular velocity, to find out the average angular velocity, you need to know the kinematics or rotational motion equation. So, what I'm trying to say is from kinematics, rotational angular velocity is equal to initial angular velocity plus angular acceleration time, right? From this is A. So from this, what you can get is that angular average or average or angular acceleration is equal to final angular velocity minus initial angular velocity upon time taken, right? So meaning that you can just plug or you can replace or basically you need to just plug over here, right? So which is equal to 20 rad or 20 pi rad per second minus which is 220 pi rad per second upon, oh no, it's not here, over 3, right? Over what? 8 seconds. We have a time taken. Just this is a time taken. So you will get this when you simplify this guy. I believe you will get 5 pi upon 3, which is equal to basically 5 upon 3 rad per second square, okay? And then which is equal to basically when you multiply 5 with 3.4, you will get 5.24 rad per second square, okay? That is it for question A or problem A. Like I said before, let me know if you have any question in the comment section. I'm happy to reply for you guys. And then could you please like, subscribe, and then share this video, okay? So let's proceed with question problem B or question number B. So question B is about the number of revolution, right? So to find out the number of revolution, you need to understand the displacement of, or like I said, the basic kinematics equation. So the displacement the rotational displacement, okay, or angular displacement, which is equal to basically, as you know, that initial angular velocity time plus 1 upon 2, right? 1 upon 2 angular acceleration time t square, okay? You need to find out the angular displacement, okay? So meaning that we have angular velocity or initial angular velocity. You can calculate this term first and then you can calculate this term second as well, or you can calculate same thing, all together. So what you can do is let me do for you guys, and then pi upon 3 multiplied with time taken is 8 seconds, right? 8 seconds. We have a rad per second over here. You don't forget that, and then plus 1 upon 2. Angular acceleration is you can replace this guy or use this guy, depends upon you can get the same result. So I'm gonna to replace this guy or these terms or this answer. So pi upon 3 rad per second square. It doesn't matter. We are going to express this in radian, right? So it doesn't matter. You need to, basically you need to just express this in per radian or rad, and then you will get basically rad as well, rad per second square, okay? This is rad per second square multiplied the time is 8, time taken is 8 seconds, meaning that 8 square, or let me write for you guys 8 seconds, right? When you square, you can get this one, and then you'll get from here where you can find out, you can multiply this one, or basically this guy is let me simplify this guy first, and then this term you will get 160, right? 165 upon 3 plus this term is equal to, let's say this guy is 64 second square, right? Right, this guy is going, this guy is cancelled with this one, as well as, because this is a second square, right? And then this is a 64, 64 by 2 is 8, and then this guy is by 2, 1. So 5 time, this guy is 64, right? 5 time 32, right? This guy is 32. Yeah, that's right. So 32, you will get, meaning that 5 times 32 is 160 pi upon 3. So which is equal to basically 320 over 3, right? That is it. And then this is the angular displacement for this question. So because you need to know that angular displacement to calculate the number of revolution. So basically what happening is that I believe you are familiar with that. Let me just clear this part. So what you can do is like I said before, so number of revolution, to find out the number of revolution, you need to understand the displacement of the angular displacement, okay? So what we can do is B, right? So the number of revolution, or N, is equal to, let's say, like I said before, from circumstance of a circle, like you know that one revolution is equal to 2 pi rad, right? 2 pi rad, isn't it? Yep, 2 pi rad. And then n revolution is equal to theta, or angular displacement, upon 2 pi, okay? So a number of revolution, or number of revolution, is equal to theta is over there, which is 320 pi upon what's 2 pi, okay? So which is equal to basically, isn't it? Yep, yeah, it is f1 to pi, 2 pi, okay? So which is equal to, basically you will get this guy is cancelled with this guy, and then you will get 320 upon 6, right? Yep, it is. So which is equal to 53.33 revolution, you can say, RPK. So that's all for this session. Let me know if you have any question in the comment section. Like I said, I'm happy to share with you guys, and then let me know if I made any mistake. I'm happy to learn from you guys. So like I said, could you please like, share, and then subscribe this video? That will help me a lot. Yep, that's all for today. See you in the next section. Have a good one. Goodbye.